Hello, good day and welcome. Today we'll be dealing with University of Abuja Physics Post UTME past question 25. It says light wave of 420 nm is shown on the surface of a metal of work function 3.2 times 10 raised to the power of minus 19 joule. The maximum energy of emitted electron in 10 raised to the power of minus 19 joule is A 0.8, B 1.2, C 2.4, D 2.8, and E 3.2. Now when you're given a question that seems complex like this, the first thing you do is you bring out the values you have. Now it says light wave of 400 of wavelength 450. Now it means our wavelength lambda equals 450 nm, that's 450 times 10 raised to the power of minus 9. 450 times 10 raised to the power of minus 9 is our wavelength. Now it is shown on the surface onto a surface of metal of work function. Work function HF naught, also called work function, is given as 3.2 times 10 raised to the power of minus 19, and this is the work function. Now the maximum energy of emitted electron is, we are asked to find the maximum energy of emitted electron, and we know that our speed of light in a vacuum is 3.0 times 10 raised to the power of 8. 3 times 10 raised to the power of 8 is our speed of light. Now how do we find the maximum energy of emitted electron? Now it's given by the formula E equals hc over lambda minus hf naught. I told you that h of f naught is the work function. Now from this particular question we have h is Planck's constant, and Planck's constant is given by 6.6 times 10 raised to the power of minus 34. So to solve, we substitute our values. We have that E equals hc minus hf naught. We know that our hf naught is the work function, which is 3 times 10, 3.2 times 10 raised to the power of minus 19. So we have that E equals 3.3 times 10, 3 times 10 raised to the power of 8 multiplied by 6.6 times 10 raised to the power of minus 34. That is our Planck's constant, minus 34 divided by our wavelength, which I explained and said it was 450 times 10 raised to the power of minus 19. And whenever you see a question and you see this n, this is like nanometers, and that's nano is times 10 raised to the power of minus 9. So we have times 10 raised to the power of minus 19 here. Then times 10 raised to the power of minus, so everything minus 3.2 times 10 raised to the power of minus 19. 3.2 times 10 raised to the power of minus 19. Now this 3.2 times 10 raised to the power of minus 19 is the work function of the metal. So we have that our maximum energy E will be, when you punch everything in your calculator, you have 4.4 times 10 raised to the power of minus 19. 4.4 times 10 raised to the power of minus 19 minus 3.2 times 10 raised to the power of minus 19. 3.2 times 10 raised to the power of minus 19. So your energy E becomes 4.4 minus 3.2 raised to the power of times 10 raised to the power of minus 19, and you get 1.2 times 10 raised to the power of minus 19. Now we need to be very careful when we are reading our questions. In this particular question, it said we should calculate the maximum energy of emitted electron in 10 raised to the power of 19 minus 19 joule. So we are calculating it in 10 raised to the power of minus 19 joule, meaning that when you get your answer, you are writing it aside this 10 raised to the power of minus 19 is like the units now. joule. So we have that our answer is 1.2 times 10 raised to the power of what? Minus 19 joule. So in 10 raised to the power of minus 19 joule, our answer will be 1.2. 1.2. And now that's option B. Option B. So the correct answer to this question is B, 1.2. 1.2. Thank you and God bless you. Please ensure you subscribe to our channel for more videos.